Hi everyone, my name is Anurupa. I work at Amazon as a product design manager. So my mentee is Theonne M. I've gotten to know her quite well over the past few months. Again, she was really quiet when she started, but I think she becomes really passionate when she talks about chemistry and physics. We did a bunch of kind of science experiments over the past few months. Learned about physics through building catapults and making catapults. Learned about chemistry through flower petal chromatography. In addition to school and magic, Theone loves fencing.
Hi there, my name is Theonne Mandela. I go to Thomas Russell Middle School. I go to Thomas Russell Middle School, and I'm currently in the 7th grade. And this is my slideshow. All my times I spent here in this magic program. And so some things I learned about Anu over my time here is that she's a mechanical engineer for Amazon. She went to Stanford University, and she believes that there should be more girls in more girls in the field of engineering. So some of the projects that I did during my time here was a catapult project, is water a good conductor of electricity project, a flower petal experiment, and a 5-second roll experiment. I'll be going through the flower petal experiment and the 5-second roll experiment in more detail, and so just some of the things I learned during my time here is I learned more about physics and projectiles, and I learned what chemicals gives flowers their color. So the first project I'll be going through is the 5-second roll experiment, and basically it's about if you drop a food item on the floor and if it was still contaminated under 5 seconds. And so our hypothesis was basically that bacteria will still be present on the food item because it'll absorb the bacteria immediately. And so my procedure for this experiment is that I had to get my materials off Amazon, and then I had to create my own agar by using nutrient agar and mixing it with distilled water and boiling it. And so then I had to pour that in the agar plates, and I gathered my food items and tested each one 2 times on different surfaces, of course under 5 seconds, and I swabbed them on agar plates to get the bacteria on the agar plates, and I just waited over time and took pictures every 12 hours. And the pictures here are basically some examples of the agar plates after around 168 hours. And yeah. This graph shows the averages of the food items on over the food items on the countertop and kitchen, and the average of the growth of bacteria that was growing on the agar plates. And this graph shows the total of bacteria colonies on each and every agar plate over the course of 24 hours to 168 hours. And sources of error I could have made in this experiment was that agar plates could have been contaminated, since the process of making the agar could have made it contaminated with the air. And then I lost images for the 3rd day because there was originally going to be a 3rd day, but I lost images for that. And the cheese was a different temperature than the bread, and colder items usually don't pick up as much bacteria as warmer items do, based on my experience. And my conclusion during this experiment was that the bread kitchen floor test one was the most contaminated food item, since there was more bacteria colonies compared to all the other food items, and the kitchen floor was the most contaminated food item. The kitchen floor was the most contaminated surface that I tested, compared to the countertop and the controls that I did. And so the second project I'll be talking about today is the flower petal pigment experiment. And it started because I wanted to learn about what chemicals went into flower petals, because everyone knows what chemical makes makes green leaves, so I wanted to know what makes flower petals. And so, like, the hypothesis was that the pigments will dissolve in the alcohol, which was going to be used later in the experiment, so I won't actually be able to see the result. And so, not really hypothesis, but more of a procedure, is that I had to collect some flower petals and a leaf, and then I had to roll a coin over flower petals under a paper towel strip, and then I had to fill a container with some IPA alcohol, and I basically made the paper towel strips barely touch the alcohol to see how the pigment would spread out. And so on the right, it shows basically the pigments that were transferred from the flower petal over on the paper towel strip, and on the left shows the alcohol, how much the pigment spread out when it touched the alcohol. And I got to learn more about the RF value, which is basically a ratio of the distance traveled by the solvent. In this case, it's the alcohol, and the solute, which is basically the pigments of the flower petal. And the red flower petal had the most RF value, and was turned actually purple, while the least was actually the light pink flower petal, because you honestly couldn't tell the difference. And so, my conclusion that I drew from this experiment is basically that darker colored petals like the leaf and the red flower petal had the most pigments on the flower on the paper towel, because you need more chemicals in order to make darker colored pigments, and lighter colored petals don't need as much since it's not as opaque color. And so the red had the highest RF value. And so what I learned in this experiment is basically that carotene pigments make up chemicals like yellow, orange, and bright red colors, while anthocyanin pigments produce red, purple, and dark blue colors. And that's all I learned from my presentation, and thank you for listening.